Well, hello from Emerald Hill Skies. My name is Doug, and we're happy to have you here tonight on a really nice, clear night. The moon's about 77%, so it's pretty bright, but I think we can still have some fun anyway. We are already looking at a double star, a binary star system. So let's see if we can get you going here. Right there in the middle is this double star. See if you can see what they call the split. Can you guys see that? Maybe we can split that double star. This is Zeta Psc. No, I'm sorry, 81 Sig. No, it's Zeta Psc. I've got the wrong name up here. Zeta Psc, otherwise known as 86 Psc. I think the PSC probably stands for Pisces. And, you know, we haven't done very many double stars, have we, at Emerald Hill Skies? But let me just make sure our audio is working okay. Yeah. We haven't done very many double stars, but a lot of people make a big deal about double stars. Let me see how far these are apart. They're about only 150 light years away. And the binary system is a type G2, whatever that means. Magnitude is about 5.2, so these are visible with the naked eye. This is 38b. So let's look that up in our book here. You guys know that we're following along in Cosmic Challenge. We're going to go to 38b, and these are autumn binary tests. Just 23 arc seconds apart. Remember, the sky that we see on one side of the planet is divided in 180 degrees, and each degree is divided into 60 minutes. And each of those minutes is divided into 60 seconds. So this would be less than half of an arc minute, which would be, so about 1/120th of 1 degree. So a very tiny space, like looking into a soda straw. But a lot of people do this, like they focus on this as like their main deal is splitting doubles. Crossing into Pisces, focused next on, he talks about this Zeta Piscium, I guess that's the Latin, huh? Will test your visual acuity even through tripod-mounted binoculars. It'll test your star hopping skills. We didn't have to worry about that very much, did we? Some observers say this looks yellowish, but Harrington says he's never noticed it. Perhaps your eye cones are more sensitive than mine. Do either one of these look yellowish to you? They don't to me. We're not stacking these. We're just seeing these at the raw 3-second captures. And we've got the gain at 400. So they're pretty bright. I suppose we could drop down either the time a little bit so that we don't have quite that much glare. Yeah, that's going to darken it up a little bit. Let's go down to 1-second captures. Tiffany, good to have you here from California. Thank you for being with us. So really, for a binary star system, I mean, we see this on Star Trek, don't we? You know, you'll have one of the people on Star Trek, they'll look up and there'll be 2 suns there. Well, that's what this would be. Any planet that's in orbit around this double star system, it would look like 2 suns. Okay, so I'm trying to learn this new software, how to make a log entry. Do I make it there? Because when I hit create log entry, there's nothing that comes up. Wonder if we're going to have to close this down and reopen it. Zeta Piscium. And then, see, our right click is not working anymore either. So I think we're going to close this down. Let's unlink the telescope first, just to do it gracefully. Telescope control. Close connection.
Telescope disconnected.
And then we're going to close this tool, and then that's called Sky Tools, and I'm still kind of learning to use it. Still brand new. You guys are learning this with me. Let's open it back up now. Okay, so it didn't remember that it was in night mode, at least up at the top, did it? That's strange. Put it back in night vision mode again. There we go. And so what it does is it sorts the objects real time. Walter Sands, G2 refers to the Hertzsprung-Russell diagram star classification. How about that, Walter? I've seen that HR whatever diagram before. G2, thanks. Kevin, good to have you aboard from LA. Okay, so now let's see if we've got the ability to connect the telescope again. Let's see. Telescope control. Connect to telescope.
Telescope connected.
Here we are at Zeta Psc. Okay, now I'm going to click Create Log Entry. I can use keystroke just M. And then, there we go. So for some reason it had lost the ability to create that. I'm going to say easy split in the RASA. In the RASA. 23 arc seconds. And I think I can just say close, and it's done. Now, it closed that automatically, and I don't really like that. Automatically mark objects as observed. Oh, I guess because I have my filter here set on show the unlogged objects only. So as soon as I created a log entry, it made it go away. That's okay, huh? The next object that it has us looking at is the Hickson 50, and I think this is a some kind of galaxy group or something. Hickson 50. So we're going to say slew to it.
The telescope is slewing.
And you can see some snow out there. I don't know whether there's snow where you are, but we probably got 2 inches. Ray, good to have you on board from Arizona. Hertzsprung-Russell. No problem. So we're slewing over to Hickson 50, and it looks like that is Cosmic Challenge 160.
Viewing Hickson 50.
And the thing about when you get up there in the higher numbers of the Cosmic Challenge, this is for monster scopes. Yes, it does appear that Walter has some experience. This is for monster scopes, and that's classified by Harrington as 18 inches and up, and we just have an 11. So I don't know. See, it looks like we're at about 35 degrees altitude. That should be fine.
Viewing Hickson 50.
I see we're at... okay, so it looks like we've already... You know this plate solving in SharpCap? Now it's called... Robin has made his own plate solving, so you don't have to go to Astro Tortilla or ASCAP or whatever I was using before. ASTAP, that's what it was. ASTAP. You don't have to use an external plate solver anymore. Robin Glover, the developer of SharpCap, has plate solve built in. He calls it SharpSolve. I think that's pretty cool. So we're going to we're just going to run our default deal here. And this is Hickson 50. And the reason we're running the default script in SharpCap is because it takes care of a lot of background things. but it'll actually plate solve again.
Viewing Hickson 50.
But it's so fast in SharpCap now, I think it's probably 5 seconds. And I had been allowing, I forget, like 25 seconds for plate solving using ASTAP. And so SharpCap plate solving now is incredibly faster. Well, it sure is good to have you here, Walter. Did you say where you were observing from, Walter? I don't know if we got your town. Okay, so there's the star field. And just for orientation now, there are a couple ways we can do this now with our new sky tools. One way we can do this is by using the atlas that's built into Sky Tools. Let's try that. So I'm going to hit A, and that brings up the atlas that's built in. I kind of like this because it's quick and low bandwidth. It's got a little crosshair there to show where we are in the sky. But I'm not sure how well we can get a sense of where we are in the sky there. So when I back off, things become real messy, see? I wonder if I can back off using the control wheel. Oh yeah, you can with the mouse. It's so fast though. Okay, so there's the horizon. So we're looking over the northeastern horizon. Here's east. And here's north. And there's the meridian. You know, that meridian is the imaginary line that joins north to south. So for orientation, this would be east. This is directly to the northeast. And look, here's the Big Dipper. Boy, that's very touchy. There. So there's the handle. And here's the Dipper. So where we're looking here for the Hickson group is at the bottom of the Dipper. So we're inside the Dipper stars here. Now get us back up to the approximate field of view of the RASA. Look, there's the Owl Nebula just a little bit north of us. Okay, so that's approximately the field of view over here. Now let's go over here and clean this up a little bit. We'll do this little thing where we click that, the histogram on the right, then we'll reset the display histogram. Oh yeah, it's already showing up there, isn't it? Or is that that's the Owl Nebula? Whoo, whoo. Boy, that makes a nice framing there, doesn't it? To be able to see the Owl Nebula right there with us. So what are we supposed to be looking at here? What are these? Where is this Hickson group with our monster scope? It has a magnitude of just 15. Oh, that's extremely dim, huh? And the angular size is just 42 arc seconds. So I'm going to guess that this is it. By the way, look up at the Owl Nebula. Isn't that beautiful? I think that's a, isn't the Owl Nebula a planetary? See the polarity of the poles here? I'm guessing that this Hickson group is right there in the middle. Tell you what, let's do. Let's hit Deep Sky Image Annotation and see if Robin's got the Owl Nebula plotted, but he does not have the Hickson group plotted because you have to use a monster scope, I suppose. So what should we be looking at here? Let's look this up. It's 160, page 160, Northwest Arkansas. Northwest Arkansas, okay. Hayfield Hermit from Michigan. Yeah, I bet you guys have a lot of snow up there, Hayfield. Where are you in the Michigan Mitt there? You're going to have to point us out here. Are you in the thumb? Okay, I'm looking up 160. If I say go green, Hayfield, will you curse at me or will you say go white? That'll tell me whether you're from University of Michigan or Michigan State. Okay, the Hickson Compact Galaxy Group. Observing compact galaxy groups from Paul Hickson's 1982 study is an interesting challenge for owners of the largest backyard telescopes, which we do not have. Most are at the edge of detection, even from dark sites, and so offer a great test of our observing skills. I especially enjoy the hunt for number 50 in his list of 100. It's comprised of 5 dismally faint galaxies crammed into an incredibly tight 42 arc seconds. Boy, how will we know if we're even close here? Now, there's a little fuzzy there, isn't there? Tell you what, let's do. Let's pump up our mids a little more. We're at 85%. Let's go all the way into 100 and keep watching that middle. There's a fuzzy and there's a fuzzy. All right, let's why is this my favorite Hickson challenge? Largely for the company it keeps. HCG 50 is just 1/3 degree east-southeast of M97, the famous Owl Nebula, which is fascinating in its own right. I rarely head out on a spring night when I don't at least stop by to pay the owl a quick visit. If the sky is clear enough, I'll often continue on to HCG 50. If I can make out even the faintest hint of it, then I know the night is, in fact, quite special. To spot HCG 50, you get M97 in the center, and then I tend to favor moving the owl off the northwestern edge. Brings a distinctive asterism of 4 stars in the shape of a Hercules keystone. Look, there it is. Here's the Hercules keystone. Okay. He says then, 9 arc minutes east of the keystone center. Nine arc minutes. For scale, each side of the keystone is 3 arc minutes. So 9 arc minutes. So this would be 3. So if we go 3, 6, 9. So somewhere right in here, apparently. Let's go over to our new atlas here. I'm going to pull this over just a little bit to make sure you guys can see it. There's that keystone. Okay, so let's zoom in. Wow, so it's going to be below the sight line of this. "20 miles northeast of Grand Rapids, right where Lake Michigan dumps its never-ending clouds. Go white! Woohoo! Unless they're playing Michigan." Okay, so below the sight line of this line, the line created with these two, you guys seeing that? Yeah. Look how that star is here. So we're talking about right here. Wow. This is stretching our RASA, isn't it? On a 79% moon-filled night. You know, I'm just on the verge of being sort of daring with a 11-inch RASA using electronically-assisted astronomy, because I'm thinking, hey, man, we can tackle this. But, boy, after 10 minutes, I'm seeing a little bit of a fuzzy, looking over at this atlas again. Here's that and that. See, that's right there and there. And there is that. You know, I do love this atlas because it is kind of working for us. Look at this. Wow, look how much detail that is. Okay, so that's that star. And that's that. And that is the star here above the P and the G, right there. So these fuzzies should be right around here somewhere. See, because that star is here in the P and the G. There's still some gray in there, but we're at the edge of existence for us, aren't we? The fact that I can see any evidence of the group's existence through a fifth magnitude sky attests the fact that we should not be put off by faint magnitude values. Notice how the magnitude for each galaxy here is its B, or blue magnitude. That is often how galaxies are listed, but it can be deceiving. In general, so-called blue magnitudes are biased toward lower values than visual. A target with a blue magnitude of, say, 18 may appear closer to magnitude 16 visually. Studies reveal that HCG 50 is an incredibly 1.7 billion light years away. No wonder it's so tough. But at the same time, what a great challenge. So he says in his 18-inch, he sees a smudge that's the combination between A and B, the two brightest in the group. And C and D are both fainter. And he never makes out E. So you can see we have the PGC numbers here. Hey, look, we're starting to see some faint, fuzzy splotches there. Again, we're assuming that on this star chart here, wait, those three would be these three, wouldn't they? These three. These two would be those two. So this is that. And this splotchiness that you see right here coming into view, what do you like better in the grainy sky there? Probably better if we dial it a little bit darker to get rid of that grain, huh? Right here, there's a fuzzy patch. Let's go ahead and do our, I like this. Splotch, 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 splotch. Now where is the E? I only see 4. A, You know what else? You know what else we can do here that's really cool? If this does not line up correctly with this star chart, we can actually rotate it. But this is lined up correctly, so we don't have to. Look, can you guys see those splotches there? Very, very faint splotches. Right there. Very, very faint. No wonder they're faint, because they're magnitude 18. And actually, if you round up, it's magnitude 19. Take a look. Those are magnitude 19. There's supposed to be 5 of them, though. And you know what I'm going to do is call up Stellarium here. And Hickson, oh my goodness, doesn't have it. All right, let's use the numbers that this atlas gives us, because we can. So let's look for PGC 34447. PGC 34447. Doesn't have that either. Look, there's 50A. So it abbreviated it. Look, see, this is why Sky Tools 4. This is why Sky Tools 4 is better. Look, there's that key, there's the Owl Nebula, there's that Keystone deal, and it shows us the location. Whoops, I held down the control key. See, I do that because I get used to holding it down in SharpCap. But it doesn't give us any objects at all. Goodbye, Stellarium. I'm sold on Sky Tools. Woohoo! But I only see 4. Well, there must be one that's covering up another one. Because in his drawing, look, I'll show you his drawing. See how it looks like a Mickey Mouse ears? And then there are 2 above each ear. A is the right ear of the Mickey Mouse when you view it head on. And C is above the A. So it goes A, and then down to the nose of Mickey is B, and then jumps above for C. Now let's see if we can find Mickey Mouse ears. Those are very far, Tiffany. Tiffany asked how far away. 1.7 billion with a B. 1.7 billion light years. So I don't really know which is which here. But back Boy, they're just on the edge of visibility, aren't they? Keystone, that star, that star, that star, right there. Just very, very faint visibility. Let's dial this back up a little bit. And then let's pump up the mids. There'll be a lot of grain, but I think we'll see a little bit more. I'm going to hold down the Shift key and pull this bar just one step to the right. There you have it, Hickson 50. Right here. Yeah, here are these two. And then this lengthwise one is right here. And then that one there popping is out here. Boy, the Hubble we are not, but this is, I think, our first time to see something magnitude 19. I would have never believed. Tiffany is in the shadow of the James Lick Observatory in San Jose. Camus is talking about focusing. Yes, we're plate solved, Camus. 1.7 billion. Yeah, we're really into smudges here. You see those little pixelations there? Those are the individual pixels of the camera. We're at 873% of the camera's optical zoom. Let me back off and show you what 100% looked like so you can see our focus. Okay, right there. That's the limit of the camera's normal visibility. I guess we could fine tune the focus. We focused a while ago. Let's go over and look at the temperature. It has dropped. Let's look at the graph. Oh yeah. We are down to 3 degrees. So we can touch up the focus if you guys want to. But let's do a quick little journal entry deal for this Hickson 50 group. Let's see. Let's close this. And then what's our keystroke for a log entry? M. Why is M the keystroke for log entry? Like make an entry or mark? What does M stand for? The only thing I can think of is make an entry in your journal. Ray, good job with the birthday party for the wife and the youngest granddaughter. All right, so we're going to go with M. We're going to say, wow, this was the toughest challenge ever. Ever. Magnitude 19 smudges. We probably would never have noticed them without the detailed atlas. Stellarium didn't even have a figure. It did have the location. Sky Tools for visual beat it to smithereens, I'm sorry to say. Smithereens. What is smithereens? What? Where did that come from? That's as bad as M for make a journal entry. Anyway, we did make out the smudges for, are we going to say 3 of the 5 group members? Because we don't want to lie, right? We never did see one, two, three. Actually, there might be the same 4 that are in our map. 1, 2, 3, 4. They're like ghosts. One, two, three, 4. It's like we're imaging them in a MRI or something. And all we can see is the proof of life. But 1, 2, 3, 4. It's 1178% of our camera's ability. We're out into the 1 pixel at a time. And this camera has millions of pixels. It's like crazy, but it is amazing that it can make them out. It's 11-inch scope, and we're trying to do what an 18-inch should be able to do. But look, right there they are. Woohoo! Okay, so let's wrap this up. Fun. Actually, we were at 26 minutes when we saw the 4th member. All right, gang, that was kind of fun. Oh my, Tiffany says Smithereens is a 90s band. Yes, Twilight Zone for sure. All right, let's go back to auto. There's the Owl Nebula, by the way. That's really cool, isn't it? Yeah, I think we do need to go focus. Okay, so let's close this atlas. And what do you say we go, let's pick a blank part of the sky. We had Stellarium open a while ago. Somewhere like this. Stop plate solving. Rats. I wonder if I can stop this.
Viewing Hickson 50.
Oh, it's not letting me stop. Oh, I shouldn't have used that silly sequence. It's taking us back into the observing mode. I was just trying to use it to quit out of the live stacking, and now it's taking us back into live stacking. It's like too brutally faithful, huh? It's this, but this is my job. I'm supposed to take you back here. Yeah, but I didn't want to go back there. All right, so this time we're just going to turn live stacking off like this, and we're going to say manually go back to 3 seconds, and manually go back to 400 gain, manually reset, and now let's go to this place in Stellarium, which should be Control 0, right? Current object. Slew.
Viewing Hickson 50.
Okay. Now let's close out this camera. And up comes Nina. Oh, you know what? I forgot. We also have to close out the focuser. Yeah. Focuser off. I mean the mount. No, I guess we don't have to close off the mount, do we? Sorry. So close the camera again. I didn't have the focuser connected. Now back to Nina. Connect to the camera. And connect to the focuser. Go to imaging and autofocus. We've got some new folks tonight. Welcome you. Thomas, Betelgeuse is in the sky. I'm not sure it's spelled exactly like Beetlejuice. I'm not sure it's spelled like that though. Tiffany's asking, Hayfield Herman is asking Tiffany if she's been to Lick Observatory. Anyway, tonight, as you guys can see, we are trying out for the first time a new targeting package and observing tool and logging tool called SkyTools 4. And I would say that one of the things I like about SkyTools 4 is the fact that now we have this interactive atlas that's always tuned to whatever object we are. And you don't have to worry about connecting the dots between your planning of your objects and your observing, like telescope aiming, and your logging, and your map of the sky. They're connected together. Now the downside is the map of the sky is more like the old-fashioned paper sky atlases that we used to use back in the good old days. Literally I've still got them and I should bring them in and show you sometimes. They're huge. They're like this wide and this high. And they are spiral bound and the pages are laminated and you would have to bring a table because the only way to use them is to bring a table. I'm not kidding. So you literally set up a table beside your old-fashioned telescope and you put this atlas there and you turn it one page at a time. So what you'd do is you'd first go to the big version and figure out what smaller version to get to. So then you go to that smaller page, like maybe you'd start on page 4 and it would show you to go to page 25. And then on page 25, you would zoom in to where the Hickson 50 galaxy group was supposed to be, and it would tell you to go to page 72. And you go back there, and then you would never be able to make out the Hickson group at magnitude 19 in a million years. You'd be lucky to get to magnitude 11. But that's the way those paper atlases go. Now, this atlas reminds me more of those paper atlases. Because if you want to have the artwork, you literally download it one object at a time. And when you call it up, you just think, why am I doing this? Why am I looking at this artwork? Whereas with Stellarium, the artwork is kind of like all integrated. You know, it's like a part of the sky, because Stellarium is looking at the entire sky as art. It's almost like using Stellarium, now that I think about it, it's like a video game, you know. And this past week, a guy helped me dumb down the video game a little bit. And that's why we're able to have Stellarium open right now. Otherwise, before this, I could never do all this at once. But he helped me dumb it down. I think we were at like, I forget, 10,000 images per something, you know. Way too many. And I slowed it down to like 10. So it's a fraction of how animated it used to be. Like, we used to be able to see meteors going across the sky, and I had them turned on. I was crazy. You could see, you know, you could see the stars twinkle. I turned that off too. So I turned all these things off and slowed it way down, and that now lets us see Stellarium, because you can see with Stellarium, it does look more like, it kind of looks more like a picture. Like, there's the Milky Way. It looks more like a picture of the sky. There, look at that. Look at these nebulae. I mean, you can tell that's a piece of art that got pasted there. But all those are already there. And look at the Milky Way. It's just so much prettier. And this is with it dumbed down. But you saw what it gave us for the Hickson group. I mean, it gave us a marker that said, see, this is HCG50A, and then it's just black. So I don't really think I'll use Stellarium regularly now as an atlas. I don't know how you guys feel. And then now we don't have to hook it to our observing package. Okay, I think I've stalled long enough that it's not a beautiful parabola, is it? But it's going to do. Focuser turned off. Camera turned off. Goodbye, Nina. Thank you for your help. Camera turned on. All right, next target is another monster scope challenge. It's NGC 2366, otherwise known as MCG Mike Charlie Golf 12-7-40. Let's see. I think our telescope is connected here, so off we go.
The telescope is slewing.
This is object 185B. Boy, that sounds high up in his pecking order. 185B.
Viewing NGC 2366.
NGC 2363 and NGC 2366. These are in the constellation Camelopardalis. This is NGC 2366. Camelopardalis. Is that named after a camel? Magnitude 13.
Viewing NGC 2366.
Lick Observatory. Tiffany did go there. Cool. Ray, that's what I do also. Sharp Cap will do an autofocus as well, but it seems really slow. Yep. And Tiff's been an astronomy fan ever since that visit to Lick Observatory. Thomas, sadly, no UFO sightings. Tiffany says maybe she's seen satellite, meteor, military. Tiffany says, I really appreciate the tech aspect. I'm all knobs and dials with my telescope. You're very kind, Tiffany, to encourage. All right, so we're starting to plate solve here. It looks like our color balance is dead on. We'll just do it again just to be sure. Let's do this stretch again, though. Let's start with this auto stretch, then do this stretch, and this stretch. That's the way Ray would have us do this. And let's pull that over right at the peak. And then let's turn on deep sky image annotation. So I don't know if that's correct or not. Let's do a solve only. And while he's doing that, of course, he does it so fast now. It's already done. My goodness, that's crazy. Robin Glover, you're a genius. Deep sky image annotation. I wondered, I didn't think it was over there. Okay, so let's remember it's right there at that star. I think I already see a splotch. Let's let it percolate some there. But that splotch, it's already there. Philip Harrington writes, will a real NGC 2363 please stand up? For years, there has been an ongoing debate over the true identity of the 2,363rd entry in the new general catalog. Many references cited as a huge area of ionized hydrogen, an H2 region, within HGC 2366, a dim irregular galaxy. Oh, I see, within 2366. That was the explanation in the press release that accompanied a magnificent shot of the galaxy taken with the Hubble Space Telescope in 1996. In part, the release said, clusters of stars and a fishhook-shaped cloud of luminescent gases glow brilliantly in NGC 2363, a giant star-forming region in the galaxy NGC 2366. The press release went on to describe how the Hubble image revealed that the brightest individual star in the region is a rare example of an erupting luminous blue variable. Recently, however, some historians have suggested that William Herschel, who's credited with discovering both NGC 2363 and NGC 2366, was describing the H2 region and the galaxy collectively when he recorded a circular patch of light with a dim protruding extension. According to Harold G. Corwin, Jr., on the NGCIC project's website, ngcic.com, the catalog number 2366 refers to both the brighter H2 region as well as its faint home galaxy. If that's the case, what is NGC 2363? Corwin's research points to an even fainter galaxy just to the southwest, which is identified as UGC 3847 in the Uppsala General Catalog of Galaxies. He contends that this second galaxy is actually NGC 2363. Fortunately, these targets are not terribly difficult to pinpoint, as they lie 4 degrees due north of the bright galaxy NGC 2403. He tells you how to get there. Okay, so let's go back out to 100%. I mean to auto. And let's open up our new shiny atlas. I'm going to hit the A key. And wow. Could that be as big as what it's impossible that it could be that big, right? Oh, we're down in the minutes, I see. So the RASA is like that. So there's the RASA's field. So 2366, right here in the middle. These two stars are those two stars. Those two stars are these two stars. Now I think we can turn something, but look at this, look at this, look at this. I'm going to close this for a minute. This is what they give you when they say you're going to view the naked eye for your context. So here's the north celestial pole right there. So here's Ursa Minor, the Little Dipper. Draco's right here. Here's Ursa Major. So this object, NGC 2366, would make a kind of the top end of an equilateral triangle with the North Star, the tip of the bowl of the Dipper, and this. So that's supposed to be your context. Now let's close that, and then they give you another thing that they call the RASA 11 view. And the RASA 11 view is supposed to have the context here, and then on the right is supposed to have your view through your eyepiece, so to speak. But look, it doesn't show anything. And I can click in this and make it a little smaller. Okay, I guess it does, huh? I just had, it was just blowing it up way too much, huh? So now here's what I was telling you about. You see how these two stars, I mean these three make this little triangle right here. It's on the left. In our real view, it's on the left. Are you able to see that? Yeah. So what you do is you grab this little side of this and you rotate this around about like that. And look, it puts those stars on the left. Is that not the funnest thing ever? And I got to drag it a little bit farther. So now I got it too far, didn't I? Got to be able to see the context of that little triangle beside it. And then you grab this little spot here, and I'm trying to match, so the top two stars of that little triangle, there, that's perfect. So see how this, let me zoom in. So with this new atlas, now we can make our atlas. Now I wonder if we can go to a full size of this. Yeah. Look how what we did. We took this little equilateral triangle here, and we made it equal. We spun it. And you can't do that with Stellarium or with any other atlas that I know of. I mean, you certainly can't do it with, what did we used to use? Starry Night Pro. I even wrote the company and said, can we not just rotate the whole field of view? And they said, you don't know what you're asking. That would be horrible. And we did it. So this atlas is actually not a bad atlas. UFO and alien life, man, no idea, Thomas. I guess if it happened, then Jesus would have to die for those people too. So I can't explain how that all works, so I don't know. I know Tiffany says it's amazing too, right? Okay, so let's put that atlas over there for a second. And let's zoom in on this fuzzy NGC 2366. And let's tell Herschel how amazing he was that he discovered these. So this we're going to call 2366. And this we're going to call 2363. And the reason why I'm suggesting we call that is because of Harrington's little drawing here. I'm spinning it around. See? So 2366 is the big one, and 2363 is the little one. You know what, Tiffany? It looks like your little Shih Tzu dog. See, here's a little leg, and there's a head, and he's going, woof, woof. Anyway, I'm going to do a journal entry here. And remember what the journal entry shortcut key is. It's M. And then you go up here and you say, create a log entry. Why does this still say Hickson? What? Click. Now it's right. Okay. This is amazing. We all love
position
this.
Synchronized. Telescope position synchronized.
What?
Telescope position synchronized.
Oh no. We all love this new workflow. Now, you know what I just realized happened? Every 5 minutes, the list of galaxies and stuff, the target list, refreshes. And when it's refreshing, it's pulling the cursor away from the window where I'm doing the log entry. So whatever keystrokes I'm doing are shortcut keys, and it just synchronized the telescope. So I'm going to have to capture this because we're done. It moved the scope on us. So let's go back. All right, but we were done anyway. Now back to our log entry. This is the main. We all love this new workflow, but it is indeed taking some getting used to. Anyway, the new atlas is grand. The way it lets us spin the sky, something we've wanted to do forever. Go, Greg, and SkyTools. The developer of SkyTools, his name is Greg. We love the detailed look of the full atlas, and we're just starting to get used to the eyepiece view. Hey, you know what else, gang? Greg told me that he's now in the process of developing, get this, he's in the process of developing a SkyTools edition specifically for EAA, or at least a module that's for EAA enthusiasts. So here's what I'm hoping. I'm hoping it'll have a rectangle that we can adjust and make it exactly the size of our field of view, and some other things, you know, stocking stuffers for electronically assisted astronomy. Anyway, we could make out here the bigger view of NGC 2366, as well as the head of Tiffany's dog, 2363. They were fuzzy, and we said they were 12 and 13th magnitude. 12 and 13th magnitude, but they were easily there in 5 minutes. Fun stuff for EAA to match the power of an 18-inch monster scope. All right, let's slew on to the next target, and I'll catch up here on...
The telescope is slewing.
Ray says, glad to see you have a clear night. We're full of clouds here. I tell you what, Ray, we've gotten our share of clouds here as well, but this one was a stellar clear one. We're just seeing you. Sorry about that, Ray. Real Sky, what do you think about UFO? Woof woof, Tiffany says. Okay, so what we're doing now is, let's close all these out.
Viewing NGC 5461.
5,461. You heard the guy say it right there on them. Are you guys able to hear him when he does his narration? Oh my goodness. Ace.
Viewing NGC 5461.
Are you kidding us? Is that for real, Ace? She says her brother took his life today. Wow. Okay. Let's just pause for a second. Lord, right now, we are taking Ace at her word here, and this is an incredible loss for her and for her whole family. We are so sorry for what has happened, and we pray, Lord, would you please reach down and in this family's life, would you please comfort them with comfort that only you can give. And any family member that's left, please help them to deal with all the questions and the heartache of this. Lord, I don't know the circumstances, but if in your grace you can somehow miraculously now ease the pain of whatever her brother was going through, and in your grace we just plead with you to take that pain away. And now, can you please take the pain away from the family members who are left behind? And there are just no words for this. So we pray for Ace, and we pray for the whole family. In Jesus' name, amen. Ace, I don't know whether you've been here before or whether it's your first time on our stream, but we are so glad you're here, and we welcome you back anytime, and we're so sorry for what you're going through, and we wish that there were words for this. If you want to say where you live, so we at least have a location in mind, that'd be grand. But at the end of the day, wherever it is, we just pray and plead that God would somehow make this easier for you, as only He can do. So sorry. Okay, we're going to push on, and Ace, we will never forget that you stopped by. Thanks, and we hope you'll stop by again. And we wish you Godspeed with everything that you've got to go through there. Okay, so this is NGC 5461, and it's object 137. And it's recommended for large scopes. 5461, number 137. Okay, so this is M101. I thought it looked familiar. And what we're looking at here are all of the emission nebulae within M101. So first let's open up the atlas and see what the atlas shows us. And sure enough, I wonder if there's a way to go into the looky there. So what we've done here is we've pasted a scaled view. We're pasting a scaled view and supposedly it matches this galaxy's scaled view. But look, that's NGC 5461. Do you think it's really off, or is what is that bright star there? Because there is no bright, unless it's that star. That's what it is. This star is that star. Now this atlas, we don't get to rotate, I think. Let's use the eyepiece view just to see what it shows us. So I'm going to close the atlas, and I'm going to reopen the eyepiece view, which is T. And look, it doesn't show us all those other names. It just shows us NGC 5461 and identifies as a pinwheel galaxy. So the eyepiece view obviously is what you're seeing through an eyepiece, but not as helpful to dissect all those nebulae, the regions of nebulosity. Clear ambient skies. You're very kind, but honestly, we don't mind it. We don't mind it a bit. Maybe somehow she thought that this was a safe place to talk about that, and so we don't mind. But that's very kind of you to speak up and support. But we're kind of a community here, so maybe she felt that. Maybe she's been by here before, and I hope so. She felt like this was a community where she could speak up. All right, let's bring the atlas back up because it was much more helpful, I think. But you know what's even more helpful in this case is Harrington's drawing. How about that? So you're welcome right now. You could just take a picture of that. Wherever you are, I'll hold it there. And you could snap a picture of it with your phone. Or if you know how to do a screen capture on if you're watching on a laptop. These are all the different regions of nebulosity that Herschel identified in this one spiral pinwheel galaxy. Okay, I'm going to take the book away, hoping that you've been able to get your phone and take the picture. All right, So we're going to zoom through these real fast. We've got our little atlas over here. Let's glance at this every once in a while. I don't think the picture, maybe it does. The fact that we can't align it hurts, doesn't it? Because that star here is off to the left, like a little bit below perpendicular left. And that star is turned almost down. So we need to rotate it about 40 degrees or so clockwise. So let's go out in the direction of that star first, and let's see if we can locate NGC 5462. And sure enough, Harrington has you don't suppose. Plate solve only. Okay, boy, that sure is fast now. Well, that's a little helpful, isn't it? Okay, so here's 5462. Yeah, I wouldn't have guessed that far out, would you? Oh, yeah, I wouldn't have guessed that far out. And here's 5461. I can see why these are identified as regions of nebulosity, because they're a little bit separate from this arm. Look at this arm here, and then look how this gas is out here separate from that arm. It's almost like this galaxy is slinging nebulosity out as it spins. Good job, Tiffany. Tiffany got the picture. Unless this is a wider arm, like Harrington's picture shows this as a wider arm, doesn't it? Like 5461, 5458. Click that off for a minute. 5458. So this little gaseous region here has its own name. I wish that had a keystroke. 5458. And there's 5455. Look at that nebula all the way out here. And here's 5453, but we don't have 5450 unless it will only show up if we zoom in. Sometimes that's the case. Yeah, 5450. Oh, I see, 5470. It looks like SharpCap is showing this list of objects, and it says it's showing us 5450, but I don't see it. Anyway, it's at the end of that right arm. It's 5455. So it should be here, shouldn't it? $54.47. There you go. Boy, that is a wide arm, isn't it? $54.47, $54.49, $54.51. Deep sky image annotation really helped, didn't it? Yes, like being thrown from a merry-go-round is exactly it, Ray. Slinging nebulosities. So let's remember this, that Messier 101, which is what we're looking at here. Oh, look, there's 5471, almost off of the frame. Oh my goodness, look, there's 5477 way down there. That is not in Harrington's list. He doesn't have it part of the overall complex, but it is at least in the frame. Look, there are a few others in the frame. 5473. And there's 5474. Oh, 54. Oh my goodness, look. 5485, 5486. $54.74. You know what? This is aligned, isn't it? Look. Here's 54.74 over here, and there's 54.74. And then there's 54.77. Actually not bad. I like that little atlas built in. Now I'm just curious. Let's go over to Stellarium real quick. We're going to go to M101. Yeah. Stellarium does nice on this, doesn't it? 5477 is right here. 5471, 5462, but not 61. 54, 55, 54, 47. It's up here. 5451 is here. 5449. I think you got to admit, Stellarium did great on that. There's 5473. It's out here. Got these two here, 5485 and 5486, that we're seeing live here on the left. Maybe there will be a place ongoing for Stellarium, right? Because that's pretty good, pretty helpful. It was just on the very, very, very small Hickson 50, magnitude 18 stuff that Stellarium let us down. Okay, away you go, Stellarium. And let's turn off deep sky image annotation and tune this up a little bit more. Just a quick screenshot there. This is M101, 20 minutes. And wow, where is that saving that? Oh, let's put it in desktop sharp cap captures. I guess I didn't put the date, did I? Bummer. Okay. So here on our, what's that, 5461, is that right? I've lost track of where we were. 5461, right? 130, yeah, 137. Because we got to do our log M. Yeah. Sharp caps, deep sky image.
Telescope position synchronized.
Annotation did great on this, as did Stellarium. We located all of these little areas of slung out nebulosity. Ray called it a merry-go-round effect. Incredibly wide area. "11 entries of NGC. It has more than any other object in the whole NGC list. Herschel drew a sketch, but there have been errors trying to make his sketch match with reality. So nobody knows for sure what he originally called them, so they've been renamed along the way. Herschel found a lot of these fuzzies. Go Herschel, huh? Some computer software programs plot 5455 as just another field star, failing to recognize its true extragalactic nature. Pretty cool. Fun that these are emission nebulae that are in another galaxy. Emission nebulae in another galaxy. Pretty fun. All right. The last object available tonight from the Harrington list is ACO 1367.
The telescope is slewing.
And this is object 163, so it's another monster scope object.
Viewing ACO 1367.
It is abbreviated in its catalog ACO 1367, but when you pronounce it, you call it Abell. It's because there are two different catalogs. 1367. There are apparently two different catalogs that have the Abell moniker, and so to make it a little more friendly.
Viewing ACO 1367.
Yeah, you heard the guy reading it, the voice called it ACO, ACO. But it's the Abell catalog of galaxy clusters. It was first cataloged as a single system by George Abell, or however you pronounce his name, Abell or Abell, more than a half century ago, and it was known informally as the Leo cluster. Its gravitational grasp reaches across a huge region of some 100 million light years wide, and it holds 117 individual galaxies lying in an average of 300 million light years away. So this is a galaxy cluster that's 300 million light years. So the light that we're seeing here, it's coming from 300 million light years away. Yeah, Stu, you're right, Tiffany. He's not here, is he? Rats. That places it at the same distance of AGC 1656, the Coma cluster, and that's another monster scope challenge. So it covers 101 arc minutes. So that's about, what, a degree and a half? And that's equal to 2 full moons stacked side by side. When you add this together with the Coma cluster, that's AGC 1367 and AGC 1656, they form what's known as the Coma supercluster. That's the closest massive cluster of galaxies to the Virgo supercluster, of which our Milky Way is an outlying member. The Coma supercluster appears to lie at the center of a galactic filament known as the Great Wall, not to be confused with the one in China. The Great Wall, discovered in 1989 by Margaret Geller and John Huchra, is one of the largest known structures in the universe and one of the first to indicate the web-like nature of the universe on the grandest scale. We now understand that galaxies appear to lie in groups and clusters, which in turn form superclusters, and beyond that, filaments. Filaments are long thread-like structures that wrap around and form the boundaries of huge empty voids of space. As to why that is, well, that will have to wait for further study, although it probably has to do with the intervention of dark matter. Of the galaxies in AGC 1367, 21 found their way in the new general catalog. The remaining 80-plus members were discovered afterward and are inventoried in a variety of catalogs, including the index catalog, that's IC, the the morphological catalog of galaxies, which is MCG. I wonder what that stood for, morphological catalog of galaxies. The principal galaxy catalog, which is PGC, and the Uppsala General Catalog of Galaxies, which is UGC, and the Zwicky Catalog of Galaxies and of Clusters of Galaxies. That's the CGCG, and others. And as might be expected, the NGC galaxies being the first discovered are typically the easier to spot. But even some of the NGCs can give you a run for your money. So then he tells you how to find this. And then he says, try to get started. This is another one you should take a picture of. What? A cluster, right? There you go. It's trying to bring it into focus. It's an amazing cluster of galaxies. All right, let's see if we can tune this thing up. So first we'll reset the side histogram, and then we'll reset the display histogram. Then we'll do a color balance, and then we'll see what we got. Which looks like barely. We can start to see some splotches there. Yeah. Wow. That's pretty cool, isn't it? Wow. Look at this spiral here, edge on. You can tell that's a fuzzy, and that's a fuzzy. Let's do this. Wow. Let's go over here and get our I don't know if that picture is that helpful. So let's drop that picture and just do outlines. Boy. You think those are, once you zoom in, are those, yeah, they're all numbered once you zoom in. So there's the overall supercluster of ACO 1367. So let's get the big picture first. That's great, isn't it? Robin Glover, you're like a genius. Robin Glover is the developer of the SharpCap imaging software. And this Sky Tools is done by a guy named Greg. I've forgotten his last name. Please forgive me. So let's start with 3860. NGC 3860. Anybody see that in our, oh yeah, there it is. Right in the middle of the sketch, 3860. 3860 is right there. Okay, so now let's go back to the screen. So there's 3860. Now I'll switch this off for a second, just so you can get a picture of where 38, so there's 3860. That's pretty much just a faint splotch, huh? But it sure stands out a lot more than the Hickson 50 group, huh? Thanks, Tiffany. You were watching my back. Tiffany's asking if you can hit the like button. And that's very kind of you, Tiffany. Ray very gently said, can we see, please? Sorry about that. Okay, so that's 3860, right here in the middle. Now let's put deep sky vegetation back on. 3861 here. I see 3862, but I don't see 3861 in the sketch. Do you guys? 3862 is here. I see. So it's flipped, isn't it? 3860. Oh, there it is. 3861. That must be big. Look at that. See that bright core? And you're starting to see an arm structure around it. See that arm structure, and then it's got some slinging out stuff here. It's like a supercluster. So this is 10 minutes. At 10 minutes, you're seeing basically all of these, just with 10 minutes of integration, which to me is just baffling. How in the world can we see something that is 300 million light years away, and we see it in just 10 minutes flat? And you think about out there in the observatory, I mean, the light is coming down and hitting that telescope in that little 11-inch tube. And those photons have been traveling for 300 million light years, and they just hit that mirror and they stopped. We just put an end to their journey. That is so wild, isn't it? Those photons traveled 300 million light years for you, and you, and you, and you, and you. For those of you who are watching this as recording, woo! They traveled 300 million years at the speed of light, just so you could see them tonight. And now they're gone, and they'll never be seen again, except there were more that were thrown out. And they'll keep going other places. I guess if they hadn't hit our telescope, they would have hit the ground out there, and they still would have stopped. So we don't have to worry about wasting them, right? We didn't waste them anyway. We're enjoying them. Okay, so 3862. Look at this sketch. My goodness. 3857. Tiffany says, I am honored, she says. That's awesome. 3859. Are you guys finding all these in the sketch? I see 3857. 3857 is down here toward the bottom. $38.59 is below that. So this is, as you go over on this part of the page, it's the bottom of the page. You kind of have to hold your drawing a little bit in your mind. This is the bottom. 3867, 3864, yeah. All the way up to the top of the page, 3840, oh yeah, 3840. So I bet if we broaden out even more, yeah, look, there's 3821. $38.84. So $38.84, Harrington has it at the edge. In his sketch, he doesn't have 3883 on there. So his sketch stretches from 3884 there's 3837. Let's do this. This is ACO 1367. Let's go here real quick. ACO, what's called Abell. Let's do that. ABELL 1367 Galaxy Cluster Hubble. The Leo cluster. You know what it reminds me of is that picture that made the rounds a few years ago called the Hubble Deep Field. Remember that? Larry Christensen says, just getting back in the hobby, bought some gear, finding my eyes are failing me, thinking about going EAA, but I have a bunch more kit to buy. Yeah, this reminds me of that picture that made the rounds, and they called it the Hubble Deep Field, remember? I wonder if this is it. Let's read the wiki article. I'm so sorry to make it... boy, that's amazingly beautiful, isn't it? Wow. Just galaxy after galaxy after galaxy. Oh my goodness. Look at all those little galaxies. Every one of them has so many stars. Look at that. Isn't that crazy? Sorry for the way this is going to hurt your eyes for a minute. Too bright, right? So it says a team of scientists decided to observe the Leo cluster with the intention of creating a catalog of extended ionized gas. This data also led to the discovery of many star-forming parent galaxies within the cluster. Most dense galaxy clusters are composed mostly of elliptical galaxies. The Leo cluster, however, mostly contains spiral galaxies, suggesting that it is much younger than other comparable clusters such as the Coma cluster. It is also home to one of the universe's largest known black holes, which lies at the center of 3842. 3842. Where is 3842? Is it off the map here? Let's go over here. Oh, here we go. It's up here. Oh, here it is. So right here, look how more galaxies come into view when you zoom in. Look at that cluster there. It's amazing, right? They're all just traveling around together. Anyway, this galaxy, 3842, has one of the biggest black holes discovered yet. NGC 3842, magnitude 12. You're about to go into it, I think. What did the rest of that paragraph say? One of the universe's largest black holes known, center of 3842, the black hole is 9.7 billion times more massive than the sun. Whoa. 9.7 billion times bigger than our sun. I can't even get my arms around that. 9.7 billion times bigger than the sun. It can be very difficult for stars to form within Leo clusters because of the infalling galaxies. They have a tendency to strip the gas away from the other stars. This led to the creation of a hot zone where stars are unable to maintain their gas long enough to properly form. There appears to be a number of subpopulations, a bunch of elliptical galaxies that seem to roughly be as old as the universe. A second population contains red sequence lenticular lens-shaped galaxies whose ages are directly tied to their mass. Did you see some of these over here? They had like, I noticed that there were lenses that stood for them. So I'm just going to do a quick thing here. Hubble Deep Field was an image of what galaxy cluster? Is this in Leo? But the Hubble Deep Field was in Ursa Major. It was 10 days. And they carefully picked a spot as empty as they could. And then they turned the Hubble toward it. And they just let it cook. It's a speck of the sky as wide as a dime if the dime were held 75 feet away. And they say it's a very small sample, but is considered representative of the typical distribution of galaxies in space. And in this one view, they found 1,500 galaxies at various stages of evolution. It's taken a while to form there because it's so detailed, I take it. So this is not the Hubble Deep Field, but it does kind of represent it. Well, I know our time is up, but I think you guys are right. Tiffany says, I'm feeling very tiny right now, laughing out loud. And Ray says, what an amazing universe we live in. Now, here's the most amazing thing. I always am amazed by that verse in the Old Testament in which it says that God made all the stars and calls them all by name. And whenever we look at an image like this and we see all these galaxies that we're starting to learn the names of them, I kind of feel like it's always kind of a tip of our hat to the God of the universe, because he created all these. He slung them out there, and he named them. Now, we're not using the same names that he uses, I'm sure, obviously, duh, but I think it shows a bit of respect when we start to kind of pick these apart and recognize the grandeur. So thanks, first of all, to him, and thanks to you for sticking with us for these 2 hours. If you were watching live or as a recording, one way or the other, thanks. One more time, we want to remember Ace, who had experienced that terrible loss, and thanks for stopping by. If this content is content that you're interested in, would you mind subscribing so you can be alerted when we do this kind of thing again? We try to do it once a week on a clear night, if a clear night comes. We try to use the best software as we can, and we used new software tonight that I think is really a step forward from what we were doing before. I really like it. Helps to get that out in the neighborhood if you can hit thumbs up. And there's a bell if you want to click a bell to be notified when we do these kind, or you can go to emeraldhillskies.com and subscribe there by using the little form, and you'll be notified via email, usually 12 to 24 hours before we start. So again, thank you guys for doing this, and thank you, Tiffany, for being kind of the room hostess, and for you, Ray, so faithful. Stu, if you come by later, and all of our friends who come by later, usually there are 200 or 300 that come by to visit at least, and we're so thankful for all of you. Pete, if you stop by from the Isle of Wight, I think it's called, welcome. And we really love you guys. It's a great community. Team astronomy. Who says you can't do astronomy as a team? So Tiffany says best wishes. Hayfield Hermit says thank you from up in Michigan. God bless all you guys, and we'll see you in the next one.